This is mathheals.com, and if you want to go here to find more links to YouTube math videos, let's take a look at matrix operations and their applications. And let's look at our first problem. This kind of reviews a little bit what we've talked about on matrices in the past. -2, 1, 3, 5, 7, -1, 2, and -3, 4, -5, 11, and -8. Now, first thing it says give the order of each matrix. Now, the order, remember, is a size, and it's rows by columns. So this one has 3 rows and 4 columns. So it's a 3 by 4. Then it says identify A sub 3, 2 and A sub 2, 3. Or explain why this identification is not possible. Well, this is rows columns. So this is third row, second column. Well, third row, second column would be -5. This says second row, third column. So second row, third column, and our answer would be 2. And those are our answers to that problem. Let's look at number 2. Got A is equal to -2, 4, 3, -1, 7, and 1. And B is 5, -1, -7, and 2, -3, and 9. And let me double check all those signs. Okay, let's go look at part A first. A plus B. When you're adding two matrices together, what you're going to do is you're going to add together the corresponding cell entries. Like we got our first number here, we got our first number here. So we got -2 plus 5. We got 4 minus 1, 3 minus 7, -1 plus 2, 7 minus 3, and 1 plus 9. Just double check myself. Okay. Well, -2 plus 5 is 3. 4 minus 1 is 3. 3 minus 7 is -4. -1 plus 2 is 1. 7 minus 3 is 4. 1 plus 9 is 10. And that'd be your answer. Now the next one is subtracting matrices. Well, we're going to subtract the corresponding numbers. So we got -2 minus 5. We got 4 minus a -1. Excuse me. 3 minus 7. Damn it. Screwed that up. 3 minus a -7. -1 minus 2. 7 minus a -3. And 1 minus 9. Double check that. Okay. -2, -5 is -7. 4 minus a minus becomes a plus, so 4 plus 1 gives us 5. 3 plus 7, 10. -3, 10, and -8. And that'd be your answer. The next one is -4a. So we're going to take -4 times all the entries in A. So we got -4 times -2, -4 times 4, -4 times 3, negative 4 times negative 1, negative 4 times 7, and negative 4 times 1. Double checking my signs. Okay. Negative 4 times negative 2 is 8. Negative 4 times 4 is negative 16. Negative 4 times 3 is negative 12. Negative 4 times negative 1 gives us a positive 4. Negative 4 times 7 is negative 28. And negative 4 times 1 is negative 4. And that's our answer. And 3a plus 2b. Well, that says we're going to take 3 times a. So negative 2, 4, 3. Negative 1, 7, 1. Plus 2 times b. So 2 times 5, negative 1, negative 7. 2, negative 3, 9. Well, we'll take 3 times every entry in A. So 3 times negative 2 is negative 6. 3 times 4 is 12. 3 times 3 is 9. 3 times negative 1 is negative 3. 3 times 7 is 21. 3 times 1 is 3. And we'll take 2 times everything inside the matrix. 2 times 5 is 10. 2 times negative 1 is negative 2. 2 times negative 7 is negative 14. 2 times 2 is 4. 2 times negative 3 is negative 6. And 2 times 9 is 18. Well, now we're going to add together the corresponding entries. So we got negative 6, plus 10. We got 12 minus 2, 9 minus 14. Negative 3 plus 4, 21 minus 6, and 3 plus 18. Negative 6 plus 10 is 4. 12 minus 2 is 10. 9 minus 14 is negative 5. Negative 3 plus 4 is 1. 21 minus 6 is 15. 3 plus 18 is 21. Assuming I didn't make any basic math errors, these are our answers for these four parts. Let's do this in the calculator. Well, we're going to go input our matrices first. I guess I got to have my calculator up and running. Okay, we're going to go into our matrix menu. So I do second, x and negative 1. If you're on a T83, you have a button that actually says matrix. I'm going to right arrow. That x and negative 1, by the way, is the inverse button. Right arrow over to edit. And A, I'm going to put in A. See how A is highlighted now? So press enter on it. The size of our matrix is rows by column, so this is 2 by 3. So put 2 in, enter, 3 in, enter. And we got negative 2, enter, 4, enter, 3, enter. Negative 1, enter, 7, enter, 1, enter. Double check my signs. And then exit out. So do second mode. Now we're going to go back into our matrix menu because we need to put B in. So I'm going to right arrow over to edit, and I'm going to down arrow to B. So B is highlighted. So I press enter on it. And put in 2, enter, 3, enter. Because it's a 2 by 3 also. And we got 5, enter, negative 1, enter. Negative 7, enter. 2, enter. Negative 3, enter. And 9, enter. Double check my signs, looks right. So I'll do a second mode, exit out. Okay. Now we're ready for our first one, A plus B. Well, I'm going to go to my matrix menu, second x negative 1. Enter on A. See, I'm under the names. So enter on A. Plus, go back in my matrix menu, second x to negative 1. Down arrow to B. Enter on it. and enter again. And we get 3, 3, negative 4, 1, 10, 4, 10. Okay, looks like we did it right by hand. Let's find A minus B. Go back in my matrix menu, second x to negative 1, enter on A, minus, go back in my matrix menu, down arrow to B, enter, enter again. That looks right. Okay, our next one is negative 4A. So do negative 4, go in my matrix menu, enter on A, and enter again. And, okay, looks like it checks. Then our last one, 3A plus 2B. So put 3, go in my matrix menu, enter on A, plus 2B, so plus 2, go back in my matrix menu, down arrow to B, press enter on it, and enter again. 4, 10, negative 5, 1, 15, 21. Good, it matches. And that's how you do it on the calculator. Now let's take a look at our next problem. So we've got A is equal to 4, negative 1, 5, 2, 1, negative 2. And B is equal to 3, negative 4, 7, 1, negative 5, 1. And it says solve each matrix equation for x. We've got x minus b is equal to a. Well, with matrices, the x is a matrix, by the way. That's why it's capital X. You can add a matrix to both sides of a matrix equation. So I can add b to both sides. And just like regular algebra, a negative b plus b would cancel away. And you'd get x is equal to a plus b. Well, that means we add these two matrices together. So 4, negative 1, 5, 2, 1, negative 2. And b, which would be 3, negative 4, 7, 1, negative 5, 1. And you add together the corresponding entries. So 4 plus 3, negative 1 minus 4, 5 plus 7, 2 plus 1, 1 minus 5, and negative 2 plus 1. Which gives us 7, negative 5, 12, 3, negative 4, and negative 1. Again, assuming I didn't make a math error. But let's do this on a calculator. Just double check myself. Need to go input our matrices in. So do second x and negative 1. Right arrow over to edit. Do enter on A. Now A here, rows by columns, is 3 by 2. So do 3 enter, 2 enter. It's hard to mess that up. Because after you get those numbers input, if your matrix doesn't look like what you're trying to input, then you know you did it wrong. And then you go back and flip it around. Like if I did 2 by 3, for example, it wouldn't look like this. Okay. 4 enter, negative 1 enter. 5 enter, 2 enter. And then 1 enter, negative 2 enter. And that's A. So I'm going to exit out. Go back in my matrix menu. Second x to negative 1. Go over to edit. Down arrow to B. Enter. And this is also a 3 by 2. So do 3 enter, 2 enter. And that's my second matrix here. So 3, negative 4. So 3 enter, negative 4 enter. 7 enter, 1 enter. Negative 5 enter, 1 enter. I want to exit out, so I do second mode. And now I just want to do, what do I want to do? A plus B. So I do second x to negative 1, enter on A, plus second x to negative 1, down arrow to B, enter, and enter again. And 7, negative 5, 12, 3, negative 4, negative 1. So we get the same answer by hand and by the calculator. Yeah, let's look at our next problem. So we got A is equal to 4, negative 1, 5, 2, 1, negative 2. And B is equal to 3, negative 4, 7, 1, negative 5, 1. Double check myself and all my signs, numbers. Okay, that looks good. We want 2x plus 5a equals b. And want to solve it for x. Well, first thing I can do is I can subtract 5a from both sides. When I do that, these 5a minus 5a drops away, and we got 2x is equal to b minus 5a. Now, we don't want to think of it so much as divide as it is multiply both sides by 1/2. In terms of matrices. Works out better that way. So these cancel, and we got x is equal to 1/2 b minus 5a. So we're going to have 1/2. B is that matrix. So we got 3, negative 4, 7, 1, negative 5, 1. Minus 5 times a, which is 4, negative 1, 5, 2, 1, negative 2. And yeah, looks like I wrote everything down correctly. Well, we do the order of operations just like we have in the past. You do what's inside the parentheses first. And you do multiplication before you do subtraction. So a lot of that's still the same. Some things do change in matrices, but that doesn't. So I'm going to go ahead and multiply 5 through. Well, 5 times 4 is 20. 5 times negative 1 is negative 5. 5 times 5 is 25. 5 times 2 is 10. 5 times 1 is 5. And 5 times negative 2 is negative 10. Let me double check all that. Okay. Now we want to subtract these matrices. Still doing what's inside the parentheses. So subtract the corresponding entries. So I got 3 minus 20, negative 4 minus a negative 5, 7 minus 25, 1 minus 10, negative 5 minus 5, 1 minus a negative 10. Okay, 3 minus 20 is negative 17. Negative 4 plus 5 gives us 1. 7 minus 25 is negative 18. 1 minus 10 is negative 9. Negative 5 is negative 10. 1 plus 10, remember a minus minus becomes a positive. That gives us 11. And now we'll multiply the 1/2 through. So we'll take 1/2 times negative 17. That gives us negative 17 halves. 1/2 times 1, that gives us 1/2. 1/2 times negative 18 is negative 18 halves. Negative 9 halves. Negative 10 halves. And 11 halves. Do a little bit of simplifying. Excuse me. So I got negative 17 halves. I got 1 half. Negative 18 divided by 2 is negative 9. And negative 9 halves. Negative 10 divided by 2 is negative 5. And 11 halves. Assuming I didn't make a basic math error somewhere, that would be our answer. So let's come up here and input these in our calculator and see what we get. So A, I'll do second x to negative 1, right arrow over to edit, enter on A. Size this matrix, rows by columns, 3 by 2, so 3 inner, 2 inner. Are those the same numbers I had from last time? 4, negative 1, 5, 2, 1, negative 2. It looks like it, doesn't it? Let me exit out, go check my B. So do second x to negative 1. Right arrow over to edit, down arrow to B. It's 3 by 2 again. 3, negative 4, 7, 1. Oh, that works out really nice. So I exit out. Now the point we want to plug into the calculator is the point where we got x by itself. So this is what we want to plug in. So I got 1 half. And I shouldn't need to put a times there, but sometimes matrices are kind of funny. We'll just put a parentheses and see what happens. Then B minus 5A. So go to my matrix menu, second x to negative 1, down arrow to B, enter, minus 5, then go back to my matrix menu, do enter on A, closing parentheses if you want, and then enter. Now we got decimals. To get rid of decimals on your calculator, you do math, enter, enter. And let's go check what I got. And it gives us the same answer. Let's look at our next problem. This gets into multiplication. And here's what I'd like to talk a little bit about what are matrices used for. Many purposes. Probably the one that people interact with the most. Some people may use matrix calculations tens of thousands of times a day, maybe 100,000 times a day. If you play a 3D game, like I like Call of Duty, then the position of a character is kept track of with a 4x4 matrix. So you start out Call of Duty, for example. It's three-dimensional. You start out the game, your character is just standing there. It's a 4x4 matrix, and it's a diagonal 1, 0, 0 else. That's your starting place. Every time you move, if you move your character with your joystick just a little bit, each time you do movement, it updates your position with matrices, and it does multiplication of matrices. You have a, of course you have this, and every time you change your scale, your rotation, or your translation. Translation is when you move your character somewhere in a game. Rotate, of course, is when you rotate your character. And scale is if is size of your character changes. All these are kept track of with matrices. So anytime you do a rotation or translation, then it's a matrix operation. It may be an understatement to say you use 100,000 matrix operations every day. It could be even more than that. Without matrices, 3D games would not exist. There'd be no feasible way to keep track of everything. It's very efficient how it does all those manipulation. Now, if you're going to go program this, you don't have to know. You have to know the concepts, like what we're showing here, but you don't have to actually individually multiply matrices together. Of course, that'd be impossible. There's functions you can call in programming languages that do all this for you. But anyway, let's take a look at multiplying matrices. Yeah, you may hate doing matrices, but if you're into 3D games, you gotta love matrices in general. Otherwise, you'd be playing 2D games all your life. Okay, B is equal to -5, 8, -6, and -7. Double check all my signs. Okay, so first thing we want to find is A times B. So we're going to take this matrix and multiply it times this matrix. And I think I'll be able to do this. I don't want to, I'm going to erase that, but I don't want it to erase what's already there. So we're going to take this row times this column. So that's what we start out with. So I take this row times this column. Well, 2 times -5. Then I'll add -3 times -6. So again, 2 times -5 and -3 times -6. And that's my first entry over here. Then, what I want to do is I want to take this row times this column. Like that. So I'll take 2 times 8 and -3 times -7. Okay, then what I want to do is I want to take this row times this column. So again, taking this row times this column. So I got 1 times -5 plus 4 times -6. Then we want to take this row times this column. There we go. I was able to do it. I was afraid I'd run into some of these others, and when I erased it erased parts of my matrix. 1 times 8 and 4 times -7. Okay, so what we get then is 2 times -5 is -10. -3 times -6 is 18. 2 times 8 is 16. -3 times -7 is 21. 1 times -5 is -5. 4 times -6 is -24. This would be 8 minus 28. Let me double check that. Yeah, -5 minus 24, 8 minus 28. Okay, so then what we get, -10 plus 18 is 8. 16 plus 21 is 37. -5 -24 is -29. And 8 minus 28 is -20. Well, let's multiply B times A. So I'm going to take B, which is -5, 8, -6, -7, times A, which is 2, -3, 1, and 4. Now, multiplication is not commutative when we're talking about matrices, which is what they're trying to demonstrate here. On rare occasions, you do come up with the same answer, but not always. Okay, so again, I'm going to take my first row. Actually, yeah, I'll do it again. Take my first row times my first column. So I have -5 times 2 plus 8 times 1. Then I'm going to take my first row times my second column. That actually happens to correspond with this cell. Like this is A11, first row, first column. This one is A12, first row, second column. But anyway, -5 times -3, and 8 times 4. Oops, I've got to erase something else, don't I? There we go. Now we're going to take our second row times our first column. So I'm going to take -6 times 2 and -7 times 1. Then we want to take our second row times our second column. So we'll have -6 times -3 and -7 times 4. So let's see what that gives us. -5 times 2 is -10, 8 plus 8 times 1, which is 8. -5 times -3 is 15, plus 8 times 4, which is 32. -6 times 12 is, or -6 times 2 is -12, minus 7 times 1, which is 7. -6 times -3 is 18, minus 7 times 4, which is 28. Well, looks good. But it's so easy to make a basic math error on these. So it gives me -2, 47, -19, and -10. Now, well, it'd be best to show it in the next example. Well, when multiplying, let me go ahead and mention it here. This matrix here is a 2 by 2, and this one's a 2 by 2. Unfortunately, everything's 2's here. But what you're going to find is that there's going to be a connection here. We're going to tie these two numbers and these two numbers. And it'll make more sense when I talk about the next example. But keep in mind that these will tell you something specific, and these will tell you something specific. I'm not going to go into it here because they're both 2's, so it would be meaningless. Okay, let's do this in the calculator. So I'm going to go to my matrix menu and enter these in. So I do second x -1, right arrow over to edit, enter on A. It's a 2 by 2, so I do 2 enter, 2 enter. And we got 2 enter, -3 enter, 1 enter, 4 enter. I'm going to exit out now. So second mode. Go back to my matrix menu, second x to -1, right arrow over to edit, down arrow to B, press enter. It's a 2 by 2, so 2 enter, 2 enter. And we got -5 enter, 8 enter, -6 enter, -7 enter. And exit out, so second mode. And now we're ready to do our multiplication. A times B. So do second x to -1, enter on A, then go back to my matrix menu, second x to -1, down arrow to B, and press enter, and then press enter again. 837, -29, -20. So that checks. Let's go find B times A. So go back to my matrix menu, second x to -1, down arrow to B, enter. Go back to my matrix menu, second x to -1, enter on A, enter again. -2, 47, -19, -10. I'm surprised I haven't made a math error so far. But those are answers. Good. This one shows what I wanted to show in terms of the size of the matrices. Okay, we got A is equal to negative 2, 4, 1. And B is equal to 5, negative 1, and 3. And first thing we want to do is multiply these together. So A times B. Okay, so we got negative 2, 4, 1 times 5, negative 1, 3. This is going to seem weird. We're going to take this first row times this first column. Well, negative 2 times 5 is negative 10. Then, I won't keep doing these red, but I'll do the first two so you see it. Then we'll take this first row times this second column. Negative 2 times negative 1 is positive 2. And let me erase those now. There we go. Then we take this first row times our third column. And actually, maybe let me write those all out, and then quit being so lazy here. First row times first column, we got negative 2 times 5. First row times our second column, negative 2 times negative 1. First row times our third column, negative 2 times 3. Then our second row times our first column. So we got 4 times 5. Our second row times our second column. So we got 4 times negative 1. And our second row times our third column. So we got 4 times 3. Then our third row times our first column. 1 times 5. Then our third row times our second column. 1 times negative 1. Then our third row times our third column. And we have 1 times 3. Negative 2 times 5 is negative 10. Negative 2 times negative 1 is 2. Negative 2 times 3 is negative 6. 20. Negative 4, 12. 5. Negative 1, and 3. So we have multiplied correctly. It's always kind of iffy. Now the size of this matrix, rows by columns. This is 3 by 1. This one, rows by columns. This one would be a 1 by 3. I told you these are going to tell us something specific. And the 2's I didn't want to go into in the last one because everything was 2's. But see these right here? They match, don't they? These have to match to be able to multiply. So those have to match. Now there are outer ones here. These don't have to match. But these give us a size of our answer. So that tells us we're going to have a 3 by 3 as our answer. Well, we do. We have 3 rows and 3 columns. Let's multiply the other way. B times A. So I'm going to have 5, negative 1, 3 times negative 2, 4, 1. Let's first talk about our sizes. This matrix here, rows by columns, it's 1 by 3. This one, rows by columns, this will be a 3 by 1. These here have to match. Well, they're both 3s, so that's good. They match. These outer ones, I'll tell you they're going to be the size of my answer. So our answer is going to be a 1 by 1. As weird as that seems. Well, let's take a look at this. I'm going to take this row times this column, which would be 5 times negative 2 minus 1 times 4 plus 3 times 1. So this row times this column. And that gives us negative 10 minus 4 plus 3, which gives us negative 14 plus 3, which gives us negative 11. And that's our answer. Now let's do these on the calculator and see if we got our answers right. Good way to check it. Even if you're doing it by hand, plug in your calculator. It'll verify basic math errors. Okay, so we're going to matrix menu, second x to negative 1. Right arrow over to edit. Do enter on A. A we said was a rows by columns. It's a 3 by 1. You can't screw this up. If you would put 1 by 3 in, it doesn't look like what you're trying to input. Then negative 2, enter, 4, enter, and 1, enter. Now I want to exit out, so do second mode. Go back in my matrix menu, second x to negative 1. Right arrow over to edit, down arrow to B, press enter. This is a rows by columns 1 by 3. So 1, enter, 3, enter. And we got 5, enter, negative 1, enter, and 3, enter. Then we'll exit out, so do second mode. And our first one was A times B, so I do second x to negative 1, enter on A, go back in my matrix menu, second x to negative 1, down arrow to B, enter, and enter again. And let me double check my numbers here. Looks like I didn't make any kind of basic math error on that one. Now B times A. So go back in our matrix menu, down arrow to B, enter. Go back in our matrix menu, enter on A, enter again. And we get negative 11. So that one checks. Let's look at our next problem. Another multiplication. A is equal to 1, negative 2, negative 3, 4, 5, negative 1. And B is going to equal to 7, 1, 2, 3, negative 5, and negative 4. Let me grab a drink here. It says find if possible the following matrices. So let's find A times B. So we've got 1, negative 2, negative 3, 4, 5, negative 1 times 7, 1, 2, 3, negative 5, negative 4. Size of this matrix, rows by columns, 3 by 2. Size this one, rows by columns, 2 by 3. These twos match. That means we can multiply them. If these didn't match, then we'd write not possible. You can't multiply them. Now our answer is going to be these outer ones. That tells us our answer is going to be a 3 by 3. Okay. I'm going to take this row times this column. So 1 times 7. And negative 2 times 3. So this row times this column. Let me double check myself. Okay. This row times this column. So 1 times 1. And negative 2 times negative 5. Okay, then this row times this column. So I got 1 times 2 and negative 2 times negative 4. Then I go to my second row times this column. So negative 3 times 7 and 4 times 3. Then this row times this column. So we got negative 3 times 1 plus 4 times negative 5. And then this row times this column. So we got negative 3 times 2 plus 4 times negative 4. Now you're going to see a pattern here that'll help simplify this. See how we got 7 here, 7 here, 3 here, 3 here, 1 here, 1 here, negative 5 here, negative 5 here, 2, 2, negative 4, negative 4. If you don't see that pattern, you don't see a pattern develop, that means you got one of your numbers wrong. So I don't know about this next one, but I know what these are going to be. It'll be like that. Now notice here we had 1, 1, 1, 2, or negative 2, negative 2, negative 2, negative 3, negative 3, negative 3, 4, 4, 4. We're going to see a similar pattern here. But I take this last row times this first column. So 5 times 7, and negative 1 times 3. Then this last row times the second column. So 5 times 1, and negative 1 times negative 5. Notice the pattern. 5, 5, 5, negative 1, negative 1, negative 1. Now that will help reduce the number of errors you might have on these. So if you're doing it by hand, look for that pattern. You know, I mean, you don't necessarily want to use that completely, but that'll help you to spot possible problems. Okay, 1 times 7 is 7 minus 2 times 3. That's 7 minus 6. This one's 1 plus 10, 2 plus 8. I'm just going across here. Negative 21 plus 12. Negative 3 minus 20. Negative 6 minus 16. 35 minus 3. 5 plus 5. 10 plus 4. Double check all those. 7 minus 6. 1 plus 10. 2 plus 8. Negative 21 plus 12. Negative 3 minus 20. Negative 6 minus 16. 35 minus 3. 5 plus 5. 10 plus 4. Okay. 7 minus 6 is 1. It's 11. 10. Negative 9. Negative 23. Negative 22. 32, 10, and 14. And that looks alright. Looking for basic math errors. Now B. B says to take B times A. So I got 7, 1, 2, 3, negative 5, negative 4, times 1, negative 2, negative 3, 4, and 5, negative 1. And that looks good. Okay, so this one, rows by columns. This is 2 by 3. And this is rows by columns, 3 by 2. Again, for you to be able to multiply these together, these numbers have to match, which they do. Size of our answer is 2 by 2. Okay, so I'm going to take this row times this column. So 7 times 1 plus 1 times negative 3 plus 2 times negative 1. So this row times this column, which tells me that negative 1's wrong. Where in the world did that come from? Try that again. 5. Okay. Then I'm going to take this row times this column. So I got 7 times negative 2, 1 times 4, and 2 times negative 1. Okay, let me double check this. 1, negative 3, 5. Oh, no, the numbers first. 7, 1, 2, 7, 1, 2. Okay, that checks. Okay, then I'm going to take this second row times this first column. So 3 times 1. Negative 5 times negative 3. And negative 4 times 5. Let me see. 1s, negative 3s, 5s. Okay, then I'll take this second row here times the second column. So I got 3 times negative 2. Negative 5 times 4. And negative 4 times negative 1. Let's see, 3, negative 5. Okay, that all looks right. got 7 minus 3 plus 10. Negative 14 plus 4 minus 2. 3 plus 15 minus 20. Negative 6 minus 20 plus 4. 7 minus 3 plus 10. Negative 14 plus 4 minus 2. 3 plus 15 minus 20. Negative 6, negative 20 plus 4. 7 minus 3 is 4, plus 10 is 14. That's negative 10, negative 12. 18 minus 20 is negative 2. Negative 26, negative 22. That'd be your answer. Assuming I did all my multiplication right. Let's go and plug this in the calculator and see what we get. So let's go input our matrices. Second, x negative 1. Right arrow to edit. Enter on A. This one, rows by columns, 3 by 2. So 3 enter, 2 enter. And we got 1 enter, negative 2 enter. Negative 3 enter, 4 enter. 5 enter, negative 1 enter. And I'll exit out, do a second mode. Go back to my matrix menu. Go over to edit. Down arrow to B. Rows by columns, this is a 2 by 3. So 2 enter, 3 enter. And we've got 7 enter, 1 enter, 2 enter. 3 enter, negative 5 enter. And negative 4 enter. So I'll exit out, and our first one is A times B. So I'll go back into my matrix menu. Second, x and negative 1. Enter on A. Go back in my matrix menu. Second, x and negative 1. Down arrow to B. Enter, and enter again. 1, 11, 10, negative 9, negative 23, 32, 10, 14. Okay, that all checks. I'm not doing that for your benefit. I'm assuming you've seen one of those. You probably can do all of them. I'm doing that to check my math. So I'm going to go in my matrix menu, down arrow to B. Go back in my matrix menu, enter on A, enter. 14, negative 12, negative 2, and negative 22. Okay, so that all checks. So far, I've batted 100% on these. I haven't screwed up math yet. Let's look at this last one. Okay, so we got A is equal to 2, 0, negative 1, 3, negative 5, 2, and B is negative 1, negative 4, 2, negative 7, and C is 5, 1, and 3, negative 2. And let me double check all those. Okay, we want A times B plus C. Well, I got A, which is 2, 0, negative 1, 3, negative 5, 2, times B, which was negative 1, negative 4, 2, negative 7, plus C, which is 5, 1, 3, negative 2. Double checking my signs. Okay. 2, 0, negative 1, 3, negative 5, 2. I'm going to add these matrices together. So we'll add together the corresponding entries. I won't show all the steps because you've seen enough of them now. I think you got it. Negative 1 plus 5 is 4. Negative 4, negative 4 plus 1 is negative 3. Maybe I would put it for myself. 2 plus 3 is 5. Negative 7, negative 2 is negative 9. Double check myself. Negative 3, 5, negative 9. Okay, now we want to multiply these together. Now this is rows by columns. This is a 3 by 2, and this is a 2 by 2. Again, to be able to multiply them together, these have to be the same, which they are. And the size of our answer is going to be a 3 by 2. Okay. So we'll take our first row times our first column. So I got 2 times 4 plus 0 times 5. Then we'll take our first row times our second column. So we got 2 times negative 3 plus 0 times negative 9. Then we'll take our second row times our first column, negative 1 times 4 plus 3 times 5. Then our second row times our second column. So we'll have negative 1 times negative 3 plus 3 times negative 9. Then we'll take our third row times our first column. So negative 5 times 4 plus 2 times 5. Then our third row times our second column. So negative 5 times negative 3 plus 2 times negative 9. Now I'm going to look for patterns. 4, 4, 4, 5, 5, 5, negative 3, negative 3, negative 3, negative 9, negative 9, negative 9. 2, 0, 2, 0, negative 1, 3, negative 1, 3, negative 5, 2, negative 5, 2. That looks good. If I don't have to see the patterns, then I did something wrong. Well, 0 times 5 is 0, 2 times 4 is 8. This gives us 0 times negative 9 drops away, so we got negative 6. This is negative 4 plus 15, which gives us 11. This is 3 minus 27, which is negative 24. Negative 20 plus 10 is negative 10. This gives me 15 minus 18, which is negative 3. Assuming I didn't make a math error. Let me double check it. And looks right. Okay, let's do it in the calculator to verify if I did it right. So we're going to put these in. Go to my edit menu. Over here. Second x to negative 1, over to edit. Enter on A. A is rows by columns, 3 by 2. 3 enter, 2 enter. And I got 2 enter, 0 enter, negative 1 enter, 3 enter. Negative 5 enter, 2 enter. Exit out, do a second mode. Go back in my matrix menu. Go over to the edit menu. Down arrow to B. And B is a 2 by 2. So 2 enter, 2 enter. Then we got negative 1 enter, negative 4 enter. 2 enter, negative 7 enter. Exit out. Go back in my matrix menu, go over to edit, down arrow to C, enter on it. It's 2 by 2. And we got 5 enter, 1 enter, 3 enter, negative 2 enter. Exit out. Now what we want to put in is this right here. So we got A. So I do second x to negative 1, enter on A, and I don't know if I can put it right next to parentheses, so I'm going to do it times. And then begin in parentheses, B plus C. So second x to negative 1, down arrow to B, plus, go back in the matrix menu, down arrow to C, enter, close parentheses, enter. And let's see if 8, negative 6, 11, negative 24, negative 10, negative 3. And we get the same answer, so that's good. And I believe that's the last problem. So let me save this.